Hello guys, this is part 2 of trigonometric substitutions for taking integrals, and in this one I'm going to show you a trick to allow you to solve integrals such as sine cubed x and so on. So the trick is whenever you see, let's say you have sine to the power of n of x, right? Like you have sine x to the power of n or cos x to the power of n, so like in this form, right? If n is even in both, then you use the substitution of 1 minus cos 2x over 2 for sine, and the substitution 1 plus cos 2x over 2 for cos. And similarly, if you have, so you have sine x to the n, and you have cos x to the m. If n is odd, so if the power of the sine is odd, but the power of the cos could be anything, right? If you have that situation, you just break the sine into sine squared, and you use the substitution 1 minus cos squared x. So let's look at some examples of these identities in practice, right? So this one here, normally there is no method right now that you cannot use biparts. Biparts wouldn't work. Use substitution wouldn't work. What else? Reverse power rule won't work, right? That won't work right now. What else won't work? It's not just like it's sine. If it was just the integral of sine, then yeah, you could have taken it, but it's sine cubed, right? So you can't just integrate it normally either. So you need another method, and this will be your method, right? So whenever you see something like sine times cos to the power of something, then you can use this. And there's more cases for this, as I'll cover in the next videos. Okay, so let's rewrite this. So this is just sine squared x times sine x dx, right? Which is just equal to, now we're gonna make our substitution. We have an odd power, right? So we can assume that the cos here is just to the power of 0, right? And we said m could be whatever, right? So it fits our criteria. So sine squared is equal to what? 1 minus, let me write this better, 1 minus cos squared x, right, times sine x dx. Can we take the derivative of this? We can indeed. Why? Because now we can actually use u substitution, right? Now we can, I'll write it. Now you apply u substitution, right? So let's say u is equal to cos x, du is equal to negative sine x dx, right? So now let's plug that stuff in, right? So now you got 1 minus u squared, sine x dx is there, we just have a negative now, so times negative 1 du, right? Now we can easily integrate this. Now we can apply the reverse power rule, right? So you're gonna be left with, we'll put a negative here, u, because that's the integral of that, integral 1, and minus u squared, so it's going to be minus u cubed over 3. We'll put the plus c in here as well. Does it actually? No, let's just put it outside. Plus c. Now u, the question was given to us in terms of x, so we're gonna substitute this in. So it's just going to be negative cos x minus cos cubed x over 3 plus c. That's your answer. Now this one, we got power of the sine is odd, cos could be whatever, right? We have, so far we know 2 cases. We know sine even and we know sine odd. And whenever it's sine odd, power of cos doesn't matter. And you'll see why. So let's break the sine, right? How are we going to break the sine? Well, what we could do is we want it in terms of sine squareds, right? So that's just going to be the integral of sine squared x squared, but that's only 4 sines. So then you multiply it by another sine x, right? And you just carry the cos squared x over. dx. Okay, now let's make our substitution. Our substitution was 1 minus cos squared x. Bracket 1 minus cos squared x. That's squared. It's multiplied by sine x. And then it's multiplied by cos squared x. Right? That's what we have. So now what do we do? Right? Well, we just set u equal to cos again. Right? So I'll do it in a different color. So apply u sub. So then it's just going to be u is going to be equal to cos x. Du is going to be negative sine x dx. Right? Now let's plug it back in. Right? It's going to be, we'll put a negative outside. We'll put a negative outside. And it's going to be 1 minus u squared times sine x is gone. That's why the negative is there. Times u squared. Right? Now can we do this? Of course we can. Du. Now the question is, do we want to expand it? Or should we do it a different way? See, I would just expand it because I don't see an easier way, right? So let's use our FOIL method. 1 minus u squared times 1 minus u squared. 1 times 1 minus u squared, negative u squared times 1, negative u squared times negative u squared, plus u to the 4, all times u squared. So you're going to have u squared minus u to the 4 minus u to the 4 plus u to the 6, u squared minus 2 u to the 4 plus u to the 6. Right? So now let's rewrite this here. Right? Actually, no, I'm going to continue it over here. So now you got the integral, right, of u squared minus 2u to the 4 plus u to the 6 du. Don't forget the negative sign. Now we can easily integrate this. So it's going to be negative bracket u cubed over 3 minus 2u to the 5 over 5 plus u to the 7 over 7 plus c. Right? What will that give us now? Now we just gotta plug everything back in, right? So where's our u was cos x? So it's going to equal to negative, we'll just put the bracket, cos cubed x over 3 minus 2 over 5 cos to the 5x plus cos to the 7 over 7 plus c. Alright, let's go to the next one. Pretty easy so far, right? Nothing too serious. It's just you have to be able to identify the powers of n or m and then know what u substitution to use after you've simplified a little bit. Because this part is just majority used to simplify. Used to simplify the integral. Right? Okay. Finally, we have one with the power even. Right? As we can see there, it's even. So now we just need to use 1 minus cos 2x over 2 because it's the sine. But we still need to break it into its sine squareds, right? So that this would just be sine squared x squared dx. Now we can apply that. So it would just be 1 minus cos 2x squared. And this would normally be over 2. But I'm just going to factor that out and just, square the top and the bottom, which would make it 1 over 4. Right? So after that, now we're going to have to expand this out. Right? Or else you can't really do it. So the integral. So if you want to expand out, it's going to be 1 minus cos 2x times 1 minus cos 2x. So 1 1 times 1 cos 2x minus cos 2x minus cos 2x plus cos squared 2x, right? So you get 1 minus 2 cos 2x plus cos squared 2x. This is what your integral is equal to. I don't like it. So it's going to be 1 minus 2 cos 2x plus cos squared 2x over 4. Right? So what do you do now? Well, the first part is easy. You can integrate this easily, right? Yeah, you have a problem with cos squared 2x, right? What is cos squared 2x equal to? Well, that's just equal to. So let me pick a good color. Oh, I already used that color. We'll use this one. Cos squared 2x is equal to 1 plus cos 4x over 2. It's just the same identity. You just got to apply it one more time, right? Like similarly of how cos squared x is equal to 1 plus cos 2x over 2, right? It's just the same thing, right? Instead of 1 being here, you have a 2 now, so you just multiply by 2, which gives you 4, right? Okay, so now let's take the integral. This one, we'll break it up. So what we're going to do is the integral of 1 over 4 minus 1 over 2 cos 2x plus 1 over 2 times 1 over 4, right, times 1 plus cos 4x, right? So now, let's move this down so we can work on it easier. Okay. So this is going to be equal. We're going to distribute the integral sign, right? It's going to be 1 over 4x, right? 1 over 4x minus 1 over 2 cos 2x is going to be sine, right? Yeah. Sine 2x over 2, which makes it over 4, plus what is it? Plus 1 over 2 times 1 over 4 times 1, so 1 over 8 x plus, so this one would just be, this is equal to 1 over 8 plus 1 over 8 equals 4x, right? Plus sine 4x over 8 times 4, right? And you don't need that anymore because we did it in one step. That's what it would be, right? We just took them each individually, and then we just expanded that final term. Okay, last one. This one, again, we have sine squared and cos squared, both being even, so we have to use the 1 plus cos 2x over 2 identity and the 1 minus cos 2x over 2 identity, as you can see here in the very first one. Okay, it's going to be 1 minus cos 2x over 2, 1 plus cos 2x over 2 dx. We have to expand this out, which is going to be 1 over 4 minus cos 2x times 1 plus cos 2x. So expanding this out, you're going to get 1 plus cos 2x minus cos 2x, which makes our job easier, minus cos squared 2x. That's just 1 minus cos squared 2x. And we just did this over here, so we can just plug that in. So it's going to be the integral of 1 minus cos squared 2x times 1 over 4 dx. So it's just going to be x minus the integral of cos squared 2x. Sorry, it's going to be over 4. Cos squared 2x over 4 dx. And, well, we know, I'll write it a little bit lower, cos squared 2x is equal to 1 plus cos 4x over 2. It's going to be times 4 because we have it there as well, right? So now we're going to get x over 4 minus 1 over 8 x, right, plus sine 4x over 8 times 4. And that's our final answer. I hope this video helps. I'll cover some more tricks on how to do these integrals in the next video. Have a good day, guys.